Okay, good morning, everyone. Right, as usual, we will start the class with your questions. So after you did the homework yesterday, which questions did you have difficulties with? Please unmute and tell me the problems, or use chat and tell me which problem you had difficulty with, and we start with that. Get going.
Number 27.
Number 27. Okay, any other questions you had trouble with? 25, I think that's what I saw. Okay, so we start with those. That's 8 o'clock. We can start. So we start with those, and if any other question comes up, please let me know. So we start with number, okay, let me take a better one. Number 25. Okay, so what is the problem? Number 25. We have the following function, f of x equal the square root of 7 minus x squared. And the question is find the domain and the range. So first, the domain. The domain, we always do it algebraically. The range is the one we just graph the function. All right, the domain. What's the domain here? Which axis will be allowed in this scenario? The minute we have a square root, the condition we should put is we want this expression right here, the one under the square root. So we need the term under the square root to be positive. So I write it just to me, under the square root to be positive. To be positive. That's really what I need. Otherwise, things don't make sense. So let us say if I put x to be 3, is x in the domain? Yes or no? Is x equal 3 in the domain? Yes or no? Unmute and answer.
No.
No. Okay, Talon, why yes? Let us get that straight. Why yes?
I think yes, because if you plug 3 in, you'd
Do it.
have. So you'd
I
have
say
7,
no.
7 minus 3 squared, which is 1.
Uh-oh.
And you would take the square root of 1.
Uh-oh. What's 3 squared?
Oh, 9. I'm sorry.
9. 7 minus 9?
-2.
Right, square root of minus 2 doesn't make sense. All right, so x equal to 3 is not in the domain because it makes the expression under the square root negative. Therefore, it's not in the domain. So let us play a little bit the game and then you know, we do it. But if I take x to be minus 1, is x equal minus 1 in the domain?
Yeah.
Yeah, because what's f of minus 1? F of minus 1. Let me take another just scratch piece of paper and do that here. What's f of minus 1? Is the
Square root of 6.
Right, because minus 1 squared is 7 minus 1 square root of 6. There is no problem with that. So that's really what we are doing. So we're finding all the x's that I can plug in into the function, and they will spit out a positive term under the square root. Now guessing, you know, doesn't sometimes get us too far. We have to do things algebraically. That's why we do those algebraically. So we need to solve, so to do this problem, we need to solve this inequality. 0 will be allowed because the square root of 0 is 0. So that's what we have to solve. So that's my starting point. All right, the 7 minus x squared is positive. I'll do it algebraically, and then I'll solve this geometrically. So what does this mean? It means 7 is larger than x squared. Right? It means, or another way you write it, x squared has to be less than 7. And then we do what we did yesterday. It means the square root of x squared has to be less than the square root of 7. Now, square root of 7 is, plug in the calculator and figure it out. It's 2 point something, so I'm not going to worry about it. But what's the square root of x squared? And that was the hard part yesterday. The square root of x squared is not x, because it's the absolute value of x. That's the hard part in this problem. Okay, because as I said yesterday, let me take x to be -1 or -2, for example. Does the square root of x squared make sense? No. Does the square root of x squared make sense when I plug in -2 for x? Yes or no? I'm not being, am I seeing answer? Yes, because this would be the square root of what? Of 4, which is equal to 2. So the square root of x squared, when x takes negative value, this is not -2. This is always the positive 2. So the square root of x squared is not necessarily x. It is x if x is positive, but if x is negative, the square root of x squared is the absolute value. So now this tells me that in absolute value, x less than the square root of 7. It means what is x? What is x? X is less than square root of 7, but not only that. Between -√7 and square root of 7. So every value between those two will be accepted. So for example, 2 will be accepted. 2 is between -square root of 7 and square root of 7. If I plug into here 7 minus 2 squared, that's going to give me square root of 3. It is correct. So everything in here will be accepted. So what is my domain?
Negative square root of 7 to square root of 7.
Right, closed here, absolutely. Closed here. So you can either use it interval notation, or you can tell me all values of x, such that x between those two values. So the only difficulty in this problem, and I know it's usually confusing, is that when you take the square root of x squared, is the absolute value of x, not necessarily x, because x is allowed to be negative. There is no problem with that.
I have a question.
Of course, go ahead.
When we're solving an equation, and
Yeah.
let's say we have like -2 squared, until it's time to like plug everything in, until we get to the final line, should we leave it as -2? No, just -2 squared. Should we leave it as? Oh, you're setting up the next problem. Never mind.
No. I'm answering your question. I'm listening to your question. What's your question?
Oh, yeah, just -2 squared. Should we leave it as -2 squared instead of 4 so that we don't lose the negative and equate -2 with 2?
What is the inequality you're thinking of?
I don't have a specific example in mind, but as we're going...
But let us say, I'll make it up. Let us say you're solving this one.
Okay.
Okay, what's the x that satisfies that? Let us say I'm solving this inequality. What would I do after that?
X squared is greater than -5/2.
Yeah, sorry, this inequality doesn't make sense. Let me put -5. Okay, it means x squared bigger, you're absolutely correct, than -5 over -2. It means x squared larger than 5/2.
Right.
All right, and then at this stage, you take the square root. Am I answering your question? Yes or no?
I'll think of a example.
Yeah, I will
how to-
appreciate it. Yeah. And then I would go from there. All right, so that's really my domain, x between those two values. Now, what's the range? As I told you yesterday, the way we're going to find the range is basically by sketching the function. Unless it's a very easy function that we know how it looks like. Once we sketch the function, we can see the range. So let's do that. So this is my function here, and I will sketch it using the calculator, just to get used to that. So this is 7 minus x squared. I'm gonna pick up my calculator and I'm gonna sketch it. So that's the one I use. So I need the square root of 7 minus x squared. So I sketch it and I try to see what I get. Okay, so trace it. So we get almost a semicircle. Do you guys see the graph? So I'm gonna graph it here. That's what I'm getting. It's gonna look something like that. Now, the domain was minus root 7. And that's why you see the graph. There is only a graph here because that's my domain. So that's my domain here, which is that's the negative root 7 and that's the positive root 7. That's the domain. Now the range is right there, all the output values. So what is the range in this problem? What's the range? 0 up to what?
Square root of 7.
What?
Square root of 7.
Absolutely, it's the square root of 7. Because what's the output here? If x is 0, the output is the square root of 7. So this point right here is 0 square root of 7. So now the range is 0 square root of 7. So even the graph is actually telling me that really this is my domain. My domain is like this, from here all the way to here. If I take any value larger than square root of 7, there is no output. What's causing this is that this will make this term to be a negative term. Okay. Any questions about 27, I guess? Okay, so let's look at the second one. Let's look at 20, sorry, this was 25. Now let me look at number 27 and see what we got. Okay, 27 is, we have a function h of u, and it's the cubic root of u minus 1. Okay, and the question is, what is the domain of this function? Okay, so we have a root, cubic root. But now, this is the question. Can we have the cubic root of a negative number? Yes or no?
Yes.
Yes, because what's the negative cube, sorry, what's the cubic root of minus 8? I mean, basically, you're asking for a number, right? When you cube it, you get minus 2, you get minus 8. Since this is an odd power, we don't really have an issue. Minus 2 to the power 3 is minus. So having an odd power in here is actually very important. So is there any restriction on u minus 1? Can u minus 1 be negative?
Yes.
Can u minus 1 be positive?
Yes.
Can u minus 1 be any number you want? And the answer is yes. So here the domain is going to be all real numbers. No problem with that. The reason is this number 3 is an odd number. It's not an even number. So we have issue with the square root. We have issue with the 4th root. We have issue with the 6th root, but we have no issue whatsoever with the cubic root and so on and so forth. Okay? All right, now the other one I see is number 8 on my lab. As I was very clear, I'm picking the same problem from the book. Okay, so it should be number 8 in the book. All right, so we look at number 8 in the book. Okay, so here we are. Number 8 in the book, because that's the one I do. You guys do the one on my lab. A stone is thrown vertically upward from the ground at speed of 40 meters per second at time t equal to 0. Its distance above the ground is approximated by the function f of t equal. So you take a stone and you throw it up, And f of t tells you how high it is above ground level. So f of t is 40t minus 5t squared. And determine an appropriate domain of this function. It means this time t vary from where to where. So this function makes sense. So this represent, f of t represent the distance above ground level of the stone. So that's really what the function of the stone. Okay, so what the stone is going to do? You throw it, it's gonna go up, basically, and come back. That's what's really going on. And it's gonna hit the ground at some point. So the question, what's in, a domain that makes sense? Let's graph this function because we can make it, we can make sense of the problem when I graph it. So how does this function looks like? This is the time here, and this is the distance. Okay, now time is positive. So negative time doesn't make sense for the domain in our problem here. So at t equal to 0, the function is 0. Now, what kind of graph is that? This is a parabola, right? It's a parabola pointing downward. So the graph is going to look something like this. And that's really reflect what the ball is going to do. The stone is going to go up, the distance increases above ground level. It hits its maximum height, and then it's going to start going down and down and down. That's really the graph. So the question is, what's the domain? I mean, which value of t are interesting? So logically, the value of t are going to be between when we threw the stone all the way till when the stone hit the ground, which is right there. So that's going to be my domain. So the question is, what's this value here? If I know it, I know my domain. All right. Is it easy to find this value? Yes or no? What happened to this value? How do we get it? To find this value, this occurs when f of t is equal to 0. So this value here is obtained when the height is equal to 0. So now let us solve for t. Now, we're going to solve a lot in this class. Whenever you have a quadratic, the way to solve is set it equal to 0 and factor. This is already 0, factor, always factor. Now what can I factor here? 5t could be factored easily, and I will be left with 8 minus t equal to 0. So basically, what's this value here? So this is equal to 0 if t is 0. We know it. We get it right here. The other one, where it is 0, 8 minus t equal to 0, it means t equal to 8. So this question mark here is going to be equal to 8. So a logical or an appropriate domain for this function is t between 0 and 8. Because for t bigger than 8, nothing's happening. The stone is already on the ground and there is nothing really going on. So a reasonable domain in this particular problem, because it has a physical interpretation, is 0, 8. All right?
What question is this on the homework?
Number 8.
Is it
It's on
number
my
8
lab. It's number
on my
8.
lab? So like number 8, because
I
mine.
didn't see this one on my lab.
Oh, really?
Yeah.
I don't know. You guys
Yeah,
asked.
neither did I.
That's fine. I'll assign it today then. Here you are. Okay? Yeah, one of your classmates asked it, so I'm just doing it. I don't memorize every problem I ask. All right. Any other question before we proceed?
I think they meant question 8 on my lab, which was number 39.
It can't be. Okay. To satisfy everyone, I will do number 39, and then I will move on. Is that clear? Okay. Let's see what 39 is. We have the following function. F of x equal 1 over x minus 3. Okay. And the question is, find and evaluate the following. F, basically F composed with F. That's really what they want. But what is f composed with f? So that's actually what they want. It means f of f of x. So they want us to find an expression for f of x. So this is a nice algebra problem. So let us do it. What is f of x? First, we compute f of x. This one. What is f of that? It's 1 over x minus 3. Okay, now, what is f of 1 over x minus 3? What does f do? It's 1 over. So what does f do? You give it an input x. It takes 1 over the input minus 3. What's my input here? 1 over x minus 3. So what f is going to do with it, it's going to put 1 over x minus 3 minus 3. Okay, now we're going to do the algebra and simplify. All right, so the first important thing, we set it up and now we do the algebra. Now, how can we do the algebra? It looks really, not really messy, it's a little bit messy. The best way to do the algebra is basically this piece in the denominator. I'm gonna write this expression under the same denominator. So let's do the bottom part. This is gonna give me 1, the same denominator, minus 3 times x minus 3 over x minus 3. Okay, we're finding a common denominator in here. So this one is here. And then after that, we fix it. All right, so it's gonna be equal to. So now it's the simplification part of the problem. 1 over. The denominator here, a common denominator is x minus 3. What's happening to my numerator is 1 minus 3 times the quantity x minus 3. So this denominator now became this expression right there. And now it's a little bit of algebra and using fractions. Now, what do we have fractions? We know that if you have A over B over C, this is nothing more than 1, basically 1 times x minus 3 over 1 minus 3 times x minus 3. And now that's the end of it. Now there's a bit of simplification, gives me x minus 3 in here. Now down here I will have 1 minus 3x minus plus 9. Finally, we get x minus 3 over 10 minus 3x. End of the problem. Okay, so if number 39 is the one you were asking, that's really how we proceed. It's a very nice problem because it requires some algebra and a bit of simplification. Right? Okay, so now we move on. I would like to talk a little bit more about composition, and then all of this is basically a review from pre-calculus, but I remind you the definition of average rate of change and so on and so forth. More composition. Little bit more. Right. When we have a function that I say h of x, and let us say fh is the composition of two functions, f and g. G of x, the one inside, sometimes we give it a name, or not actually, a lot of time, usually we call this the inner function. The one inside, whatever we, and f, we call it the outer function. It's a language I will be using a lot throughout the semester, inner, outer, especially later on when I hit the derivative. But now I'm going to ask you the following question. My question is simple, very simple. So my question is, you have a function h of x is, I'm giving you h of x is square root of x squared plus 1, very simple. I want you to give me two functions, f and g, such that the function h is the composition of f and g. Okay, so I want you, basically I'm decomposing the function. This is h. I want you to give me two functions. So when I take their composition, I get h. So how I decompose a function. Now, before you give me the answer, because I'm sure a lot of you know it, let me give you an idea how we do those problems, and then you do it. The way I think about those is the following. If I am evaluating an expression like this, what would I do first in my head? As we did a little bit before. First, I evaluate this, and then I take the square root. That's what we do algebraically. So now, I think I give you enough hint. What's the g and what's f? And then we're gonna check our answer. So what should be the inner function? And what should be the outer?
The inner could be x squared plus 1, and
The
then
inner, which is g in my case, x squared plus 1.
the outer could be square root of x.
And the outer is the square root. That's really what we do in our head. We first, if I'm evaluating this, I first compute that, and then I take the square root. All right, now let us check. I always check because we all do mistakes. So let me check. So I'm going to take, I will take your choice and I will compute f composed with g. So according to our choice, this is f of g. It means f of, what's g? X squared plus 1. That's what g does. What does f do? It takes the square root of x squared plus 1. Absolutely correct. This is my function h of x, and that's really how we check. Okay, I'll ask another, again, another simple one. Actually, I have two more, and then we proceed. Suppose, so question is the same type of questions, and 1 over, let us say, the cubic root of x squared minus 4. And the question is the same. I want f and g such that I want to be written f composed with g. So you have to give me a choice for the inner and a choice for the outer.
Is that the cube root?
Yes, that's a cubic root. Yes. So I'll rewrite it to make sure you understand. I don't know if I did a better job. Yes. All right, I want a choice. Now the choice is not unique. It means two students can give me different choices and they are both correct. Okay, one student is giving me for the inner function, the cubic root. And for the outer function, the student is giving me 1 over x. It should not be h, it should be f. Is it a good choice? Is it a correct choice? I don't know, I think. Let me check it. What is f of g of x according to the choice our classmate did? G is the cubic root of x squared minus 4. What does f do? F, it's 1 over your input. So that's my input here. F is 1 over the input. So f is 1 over my input, x squared minus 4. Absolutely correct. All right, so it doesn't have to be one choice, but whatever the choice that your classmate picked is absolutely correct. Okay, I'll finish with one and then we proceed. So my last example, I will give you the following. I'm going to take f of x equal to this big F, 1 over the square root of that. Okay, and the question is, I want 3 functions. Find 3 functions, f, g, h, such that My function f is the composition of the 3. So we talked about composition of 2. I can talk about composition of 3 functions. So there is no reason why not. I can talk about composition of 15 functions. Okay, so I'll give you a minute to think through that. Okay, anybody has any idea? All right, so I'll start picking up. Sorry. Okay, so first, if I'm doing this in my head, one possibility, I first can compute this quantity. So I can take my h to be, sorry, I take my h to be 2 plus the square root of x. I compute that. And then my second, so I'm following your classmate. I said, you know, once I do that, then I can take its square root. So I evaluate this, then I take its square root. And once I do this, I can take the 1 over x. So that's a possible choice. Let me check it for you. So let me check that. So I'm going to compute f composed with g composed with h. So let's see, what does this mean? So this means that this means the following. You start with h of x, you evaluate it, then you take g of it, and then we take f of it. That's exactly what this means. All right, so let us compute that. So it's f of g of. What is h according to your classmate? H of x is this. Okay, now, what does g do according to your classmate? So g take the square root of whatever you give it. So if you give it this, it takes its square root. So it's going to be f of the square root of whatever you give it. Now what does f do? It takes 1 over, sorry, my apology, this has to be f. Sorry. What does f do? It takes 1 over what you give it. So if you give it that, f will take 1 over it. End of the problem. Okay, so that's how we decompose functions, and this is an idea that we get introduced to it now, and then we will be using it quite a bit later on in the course. All right. We finished section 1.1 by talking about, again, the notion, or I think I will remind you of the idea of the average rate of change. Average rate of change and secant line. Okay, so before we take the formal definition, let me give you a very straightforward example why this idea is really important, very important. So suppose, you know, I have a town, and, you know, a town that I make up, and the population of this town is given by the following table. So that's the population, and that's the time in year, and that's P of T population. Okay, and let me take T equal to 0 correspond to the year 2000. So, and I'm saying it's a town that we make up. And I say initially in the year 2000, the population is 10,000. And after 5 years, when we made the census, the population was 10,400. And after 8 years, so we did the census at different time interval, the population grew to 7,000, that much. And my question is simple. You know, whenever we have population, we would like to know how fast this population is growing. So my question is, when does the population grow faster? When the population grows faster. Between t equal to 0 and t equal to 5, or between t equal to 5 and t equal to 8. When was it growing faster? Not growing more, faster. So what would be your answer? Okay, Luke is giving me between 5 and 8. Anybody else? Anybody else? When was it growing faster? And what is this number that we have to use to figure out when is it growing faster? Everybody agree between 5 and 8? Everybody, I think, is correct.
Yep.
What?
Yep.
Yep, okay, let's see what. Between 0 and 5, it means within a period of 5 years, so we're gonna call this and change in 5 years, the population grew from 10,000 to 10,400. So the population, so we say that the change in population is 400. So between 0 and 5, the population was growing at which rate? The population grew by 400 over a period of 5 years. So the population was growing by how much per year? 40 divided by 5, it means the population was growing at the rate of 80 people per year. Okay, so that's by how much it grew over how long it took. So 400 within 5 years, it means it's averaging 80 people per year. However, what's happening here? Is it still growing at 80 people per year? What's happening here? Between 2005 and 2008, it means within a period of 3 years, the population grew by 2,070. So of course it grew less, but over a shorter period of time. So to be able to compare, I really would like to know how much per year. So here it grew by, that's how much? It grew by 270 over a 3 years period. It means it grew by 90 people per year. Okay, so to be able to compare the speed at which the population is changing, I really have to compute what we are going to call the average rate of change. So on average, here it was growing by 80 people per year. On average, this is growing by 90 people per year. Why we have to compute the average? Because knowing the change doesn't tell me much. If this changed by 400 from here to here, by 270, but this doesn't tell me which one is faster. I have to compute the average rate of change to be able to find that. So let us define normally what's the average rate of change. And the way we need it basically is to compare the speed at which something changes. That's really what matters. The speed at which the population is changing, the speed at which bacteria grow. That's really what matters in this case. So let us define average rate of change in a very formal case. So definition. So suppose we have a function f of x. So definition of the average rate of change. Okay, so suppose we have a function. So let y be a function of x. Sorry. If sometimes you don't see or I go off the screen, let me know because, so suppose y is a function of x. So right here, I will sketch the graph that I will go back to it over and over. So that's my function. Okay. Then suppose I take 2 points, A and I take to point B. So this is my input X, and this is my output Y equal f of X. So when we think of a function, the way we actually think about it is that as X changes, if the input changes, f of X, it means the output is actually changing. That's really what the function is, the way we think a lot of time about a function. So what is the change? When I talk about the change in X for X between A and B, so the change for that we denote by delta X, is the following. It means if we go from here to here, so imagine we're moving from here to here, my input changes. Delta X is by how much my input changes. So delta X is B minus A. It measures how much my input is changing. Now, as we move from here to here, my output changed. So my output was right there. This is f of A. And then it's changed, like the population changing. So this is B, this is f of B. Okay, so my output changes. So the change in Y, for X between A and B, denoted by, so we denote the change by delta Y or delta of f of X. So we use either notation. It's defined by is how much the output change. It means it's defined by f of B minus f of A. So by how much the output change. Okay, so let's go back to the picture right here. So what's delta X? When we go from X to B, delta X is that, by how much the input is changing. What's delta Y? Again, the picture. At A, the output was here. Think of the scenario like a population. At X equal to A, the population is right here. At B, we are right here. So what is the change? It's from here to here. That's f of B minus f of A. That's the delta X. Another way we can see the change is here. We're going to see it two places. This is also delta X. And from here to here, that's the change in Y. This is delta Y, which is f of B minus f of A. Okay, so as we go from here to here, the output was, we were right there, and the output changed. And that's what we call the change in Y. Now, what's the average rate of change? The average rate of change is the change in Y, by how much Y changed, it's like how much the population changed, divided by how much X changed. So basically, it is f of B minus f of A divided by B minus A. Okay, so that's the definition of the average rate of change. And that's exactly what we did with the population. So when I gave you the simple example of the population, and that's really what I computed. When I computed the change in population divided by the change in time, which gave me the average rate of change. It means on average, how much the population was changing per year. Now, this is the average, the formula for it. Now we're going to interpret this average graphically. So graphically, what is the average? So graphical interpretation of the average. So I'll keep this picture here in front. It's absolutely a crucial picture. So the graphical interpretation. Of the average rate of change. Okay, graphically. To be able to interpret graphically, I have to define, okay, let me show you on the picture what it's going to be, and then I will write it. Watch what the average rate is. It's this piece from here to here, that's the rise if you want, divided by that. So graphically, the way we're going to interpret it is the following. I'm going to take the line that's joined the following point. So this point is A, f of A, and this point right here is B, and the other is f of B. I will take the line that is gonna join the point A, f of A to B, f of B. This line, the red line. This line, we will give it a name and we will call it a secant line. Okay, so the secant line is the line joining, so it's secant line, that's my line. Secant line is the line that joins. So when I talk about a secant line, this secant line is on a graph, is the line that joins the 2 points, AF of A and BF of B. It's the straight red line that you see. Now, what's the slope of this line? What's the slope of the secant line?
F of B minus F of A over B minus A.
Exactly, because that's a line. It joined 2 points. What's the slope of a line? It's the change, F of B minus F of A, divided by the change in X over the change in Y, B minus A, which is exactly the average rate of change. Okay, so the average rate of change, we can compute it, of course, we just plug in numbers, but graphically, the average rate of change represents the secant line, the slope of the secant line that joined the point AF of A to BF of B. So that's the graphical interpretation of the average rate. So physically, what the average rate represents is on average, how much the function changed per unit. Graphically, it represents the secant, the slope of the secant line. So let me do again a very straightforward example for the average rate for the last few minutes we have. Again, I will use a table because graph is just plug-in formula. So suppose an object is moving, a car is moving, and I'm going to give you the distance traveled by the car. So time, let us say here I give you time in time in hour, and the distance in miles. Okay, and I will make up some data. Can you put the paper back up? Which paper? This one? Makisha? Okay. So at t equal to 0, the distance is 0. After 2 hours, the distance that the person has traveled is 100. After 4 hours, it's 250 miles. So of course, and after 6 hours, he had the total distance traveled is 320. So d of t is total distance traveled. All right. So we graph it a little bit using the data we have. At 0, I am at 0. At 2, we are at 100. So let us say this is 100. At 4, we went all the way up to 250. So it should be somewhere in here. And 6, it's 325. So that's 250 here. 325 should be somewhere in here. So the graph looks like that, increases and go like this. Okay, that's how the graph looks like. So my question is fairly simple. Find and interpret it, okay? Find the average rate of change of the distance between, let us say, t equal to 4 and t equal to 6. Okay, so that's computed and then we interpret it. Okay, so what's the average rate of change? Okay, is between t equal to 4 and t equal to 6. The average rate of change is by how much the distance changed divided by how long it took. So the formula tells me it's the distance at 6 minus the distance at 4 divided by 6 minus 4. So I use the formula verbatim, then I interpret every aspect of it. So the distance at 6 is 320 minus the distance he has traveled is 250 divided by 2. And this is gonna give me 250, so that's gonna give me a 70 divided by 2, which is 35. Okay, so far I'm only computing numbers. Now let us interpret every single one of them. So I'll go back to my picture. What is my average rate? It's d of 6 minus d of 4. Very good. What does this represent in terms of the problem? D of 4, it means the distance the object has traveled after 4 minutes. So after 4 hours, he had traveled 250. After 6 hours, the total distance is 320. So when I'm taking the difference, that's here, that's the difference. This is d of 6 minus d of 4. That's the change in the distance. In terms of the problem, what does it represent? Please, in mute, answer the question. What does this change of distance represent? The object is moving. After 4 hours, he had traveled 250. After 6, he had traveled 320. And I take the difference. It means, what am I really looking at? Not yet. This is the second answer. I'm asking only about that piece, not the whole picture. What does this quantity? So when I'm computing this, I'm getting 320 minus, I'm getting 70. What does the 70 represent? The change in what? It's correct.
The change of speed?
How much more distance?
No, not the change in speed. Not yet. It's miles.
Maybe just the more distance.
Change of
Right.
miles.
It's miles. That's miles. That's how much he traveled between t equal to 4, t equal to 6. We're not up to the speed yet. So when I compute this change in y or in change in distance, this tells me how much the person traveled between 4. So the unit here is 70 miles. That's the change in the distance. That's my numerator. Now the change in t, it means it's how much time it changed, 2 hours. Now the average rate, so that's the change in distance. Now the average rate is what? It's how much the distance traveled between 4 and 6 divided by the time they took. So what's going to be the unit here? So the unit is going to be, so that's 35, of course. The unit is going to be miles per hour. It means the average rate of change in this particular problem tells me what you guys told me before. The average rate of change represents the average velocity between 4 and 6, or in your language, the average speed between the time t equal to 4 and t equal to 6. So the average rate of change basically tells me the change, the average change per unit. So it tells me by how much the distance, which is mile, change per unit, which is hour. And graphically, what is the 35? Graphically, the 35 is the following. If I take the line that joins the point 4 and this one, and I take this point and I draw the line between them, this line. We know what's the slope of this line. The slope of this line is the rise here over the run. So the slope of this line is actually the average rate of change, because it's how much distance was traveled. That's what the meaning of the output, divided by how long it took. So this is represent the average, write it down here. This represent the, in this particular problem, the average speed of the object. The unit is miles per hour. So average velocity is going to play, up to expect, an extremely important role in our class. Okay, so that's how the average velocity is actually change of distance over the change in time. And graphically, we represent it by the slope of a cycle time. Okay, sorry to take you up. Time is up. As usual, I'm going to put the problems on my lab, and I will put the problems on Brightspace and try to put the same problems on both. For those who have any questions, you guys can meet me in my office hours. All right, any questions?
Professor?
Go.
On the exercise, I'd like to introduce myself to the
Oh,
class.
I'm sorry. You should have reminded me.
Yes, I'm sorry.
Okay, can you guys hang on for 2 more minutes? Our class have an SI, where SI stands for Supplemental Instructor. And he's a student like you, but he knows the material very well, and he will be helping me throughout the course. And now I would like him to introduce himself, so I will pin him down. I think I can do that here. Yeah, and please introduce yourself. No, can you pin yourself down?
I think so. Sure. Hi, my name is Carlos Reyes. If you can see me in the chat, hello, I'm waving. I am the SI leader for this course, and so I've already taken the course, and I know what it takes to succeed. So I can help you to better, better retain information, and help you to do better, learn better study habits if you attend our my SI sessions that I will be hosting twice a week for 15 minutes a piece. SI attendance to these sessions has correlated with better grades and in the course, but it should be mentioned that it's not an easy fix, so you can't just, one and done. You should attend them regularly. So in these sessions, we'll be, going over the material that we learned in class, doing activities, games, maybe in a couple of quizzes that are not graded. This is purely extracurricular, and it should be taken as that. It's nothing special. You don't need to attend these, but you should probably do it if you are struggling or just want to do better in the class. So in the chat, I have included my email, so you can email me any day or night, preferably during the day. I probably won't answer you if it's like 2 in the morning, but you never know. And there's also a poll in the chat, and so you click on it and it'll show a bunch of times, and you just pick 2 of the times that best work for you to have these sessions. So preferably if you if it's like a Monday in the morning, you can click like Monday, I don't know, this thing's right here, like Monday 11 a.m. to 11:50, or if you want to do it directly after class on Wednesday, then we have a 9:15 a.m. to 10. But it's up to you whether you want it. And if you can't meet in those times, I am also a tutor. So I can also tutor you privately if you want. My times are in the chat for you to look at. So if you can't attend these classes, or you just want to be like more one-on-one, then you can sign up for tutoring. Now, once you can do that by going to Navigate, and there should be a Get Assistant button. So you just fill it out and then follow the steps and look for my name, and that is also in the chat. So if you have any questions.
Sorry, Carlos, are you gonna put all this on Brightspace?
Yes, I will put it on Brightspace.
Okay, so everything will be on Brightspace, so you don't have to worry
Yes.
about the chat. Everything
Yes.
will be clear on Brightspace. Go ahead, sorry
Yes.
to interrupt you.
It's okay. So I will put this on Brightspace after this class. And so if you have any more questions about this, feel free to email me. And, I just hope we have a good semester. So yes. Are there any questions right now? No? Okay, that's fine.
Okay, good luck, guys, and we'll see you all tomorrow. Bye.
Bye. Bye.